If you are building messaging applications in .NET and you're using AWS, eventually you will have to glue together services like SNS, SQS, or EventBridge, background processing, and message handlers. Now you can go ahead and build all of this yourself from scratch, or you can use AWS Messaging. In this video, I'm going to introduce you to the AWS Messaging library and how it can make your .NET messaging applications simpler. AWS Messaging is the official messaging library for AWS, who is also the sponsor of today's video. This library is built and maintained by the AWS team, and it aims to simplify how we can build messaging applications in .NET with most of the common use cases such as publishing messages to a queue, consuming them, and publishing to a topic. If I jump into the GitHub repository for this library, we'll be able to find many useful examples of how you can get started with this library. I'm going to walk you through the most important things that you'll need to know, and we'll start by installing the AWS Messaging library. So let's head into my .NET applications and see how we can start using it. I'm going to start from a mostly empty .NET application, and let's right away go ahead and install the AWS Messaging library. I'm going to install the latest version at the time of recording this video, which is 1.0.0. So let me go ahead and install this, and now I can close this down, and then let's discuss what we need to do to integrate this. This library exposes an extension method on the iService collection, which is called add AWS message bus. We can pass in a delegate to configure the actual message bus, and then this exposes some useful behavior that we want to call. So we're going to start from the vanilla example, integrating with SQS, and for this you have to configure an SQS publisher. This allows us to provide a message type that we're going to be sending to a specific queue. So I would have to specify my type here, which I currently don't have. This would typically be some sort of event. And then we need to specify a queue URL where we are going to be publishing this event. So let's actually build the infrastructure to support this. Let's say I create a folder, which I'm going to call contracts, and I'll create another folder which I will call models. The models are just going to contain my input contracts for the API, and for example, I'm going to create a type called order DTO. Here's what I'm going to define inside. The order is going to require some sort of identifier, a customer identifier, the total amount, the items, and the order date. I'm also going to copy the same properties and map them into an event, which I'm going to call the order created event. Something like this would be very similar to event carried state transfer. A simpler approach could just be including the order ID on the event and then fetching the other details at runtime, but I'm just going to copy everything to make the example simpler. So we have our event type. We can specify it when calling the add SQS publisher. So let's specify the order created event. And now we're missing a queue URL. So we can obtain this value from the AWS console. So let's go ahead and actually create our queue. I'm going to jump into the simple queue service, and right away I'm going to create my queue. I'll choose a standard queue. I'm going to call it AWS Messaging Dev Orders. This is the prefix for my application, the environment where I'm deploying to, in this case just my development environment, and then the orders is the actual name of my queue. I'm going to keep everything with the default settings, and I'm going to go ahead and create this queue. So now that we have the queue created, I can grab the queue URL from here, and I can specify this inside of my application. But just hard coding the queue URL like this isn't really a best practice, so we can improve on this by introducing an object that's going to contain our configuration values. So I'm going to create a new type in the root folder, and I'm going to call it AWS Resource IDs. I'm going to bind to this value from a configuration section called AWS Resources, and then the actual value that I have inside is the order queue URL. So let's define this property, and by default it can be empty, and inside of my application settings I'm going to define a section called AWS Resources, and then let's define the order queue URL, and here I'm going to provide the value that I copied from the AWS portal. So when we start the application, we'll need to get this value somehow. So how you can do this is by saying something like this. I'm going to new up a new AWS Resource IDs object, and I'm going to bind to it from my configuration. So now I can use this object to specify the order queue URL. Then we can go ahead and define a minimal API endpoint. Let's say the route is orders is going to be an async endpoint, and it's going to accept an order DTO. And then the important abstraction, the iMessage publisher. This is coming from the AWS Messaging namespace, and this is the abstraction that you can use to publish messages without having to specify what is the target service where you're going to send this message. This is actually taken care of in your configuration here by specifying the event type and which type of publisher you want to use. You can publish this type using the message publisher, and it's going to take care of routing that message to the correct infrastructure component. So after validating the order, I can go ahead and say await message publisher publish async, initialize a new order created event, and then I'm just going to map the respective property. So let's say order ID is coming from the order, the same for the customer ID, and for all the other properties, I'm going to pass in the items, the total, and finally the order date. This is going to publish my event to SQS in this example, and then I can say return results OK, and I won't return anything from this endpoint. So let's go ahead and test this out. I'll start the application and place a breakpoint here. Here's the request that I'm going to send to my API. So let's hit send, and we land on our breakpoint. And we're going to go ahead and execute the message publisher publish async call, and you can see that this completes. If I open up the console, you can see we have some logs from the AWS SDK. This is pertaining to finding the respective credentials or our identity principal. And I'm going to press continue here and jump into the AWS portal. From the interface where we defined our queue, I'm going to go to send and receive messages, and let's poll for messages. And you can see we have one message inside that contains an envelope. Now this is using the Cloud Events standard to represent the actual messages, but you can see that the contract is the order created event. So we have successfully published our event to SQS using the AWS Messaging library. But we're not only interested in publishing messages, we also want to consume them. And because SQS uses polling, there's a method here called add SQS poller, which you can configure, and you just have to define which queue you want to poll from. We already have the order queue URL, so by just calling this, you can configure the respective poller, and it's going to poll this queue and delegate any messages to the handlers you have configured. Now we don't currently have any handlers, and to add a handler, you can call the add message handler method. This accepts a type which should implement the iMessage handler interface. So let's go ahead and create a handlers folder, which is going to contain my handler, and inside of it I'm going to create a new type called the order created event handler. So as I said, we have to implement the iMessage handler interface from AWS Messaging, and here we specify the message type that we want to handle. We need to implement the handle async method, which contains our message envelope, and we can use this to obtain the contents of the message. So on the envelope, you can access the actual message, and then here are the properties of our message type. Now I'm going to inject an iLogger and specify the order created event handler. I'll make the method async, and then I'm just going to drop in some dummy implementation that's going to represent my message processing. So because I already have a message in the queue, I should be able to place a breakpoint here, and when we start the application, we should see this breakpoint hit. Now obviously, we also have to define our message handler, so let's specify the order created event handler as the argument here, but just specifying this isn't enough. We also have to specify the event type. Now I would have thought that this is kind of redundant, as you already have the message type as part of the message handler contract, but this is what the API looks like in this version of the NuGet package. So let's go ahead and start this. And you should see that our breakpoint hits. As I said, this is because we already have a message in our SQS queue. If I open up the console, you can see a message from AWS Messaging that we've started polling this respective queue. So every time we find a message from this queue, we're going to invoke the handler. If we take a look at the order created event, you can see it contains the respective details, and then we can go ahead and implement our business logic. Now, if we are successful, we should return a message process status of success. Otherwise, we can return a failed message process status. I'm going to press continue, and this is going to remove this message from the queue. Now, if we run into a failure when processing a specific message, it's actually going to be retried. And you can configure how often this occurs by setting the backoff policy. And you have a couple of options. You can either use no backoff, which means it's going to be retried immediately when it's received again from the queue. You can use a fixed interval, or you can use some sort of exponential backoff. Let's say I want to use an exponential backoff, and it's going to keep increasing the backoff time until it reaches the backoff cap, which by default is 1 minute. So this is how you can improve the resiliency of your messaging applications when you keep running into failures. And I think it's excellent that the AWS Messaging library supports all of this, as this is basically most of the building blocks you would need for a typical messaging application. Now, let's say we don't just want to publish to SQS. Let's say I want to publish to an SNS topic and have the message distributed to multiple queues. Well, we can do this. We can say bus add SNS publisher. Again, we have to specify our message type. Now, in this example, I need to provide a topic URL instead of a queue URL. So let's go ahead and create that in AWS. I'm going to look for SNS, which is the simple notification service, and this allows us to implement publish subscribe support. Now I'm going to choose just a standard topic, and I'm going to give it the same name as I called my queue. For all the other options, I'm going to leave them with the default values, and then let's create my topic. Now the next thing I need is a subscription, and here I can choose what is the destination for the actual message sent to SNS. Now I want to connect this to my SQS queue, and I have a couple of them, but the one that we are looking for is AWS Messaging Dev Orders. So let's go ahead and create this subscription. Now, just to make the example more interesting, let's go ahead and add another subscription. So I'll go back to my topic, click Create Subscription. I'll choose SQS again, and then I'm going to add the AWS Messaging Dev Messages queue, which I had from before. So let's create this subscription. And now this topic has 2 queues subscribed to it. So what should happen when I publish a message to the topic is it's going to distribute the message to both of the queues. We need to grab the queue ARN, which we have here, and we're going to add this to our application settings. So let's go back to the application, and inside of the app settings, I'm going to create a new setting called order topic URL, and I'm going to paste in this value. So let's create our respective property. On the AWS resource IDs type, I'll say public string order topic URL get set, and let's say the default value is an empty string. Now, instead of using the queue URL in my settings, like here, I can now specify the topic URL. I'm going to comment out the SQS publisher, and let's restart the application with everything else remaining the same. So I'm going to start the application, and let's see if we are able to publish the message. You can see that this completes successfully, and back in the application, I immediately hit the breakpoint in the order created event handler, which means that our poller picked up the message from our queue, and then it invoked our message handler. Now I'm going to stop this and go back to the AWS portal, and from the simple queue service, let's just take a look at any available messages inside of this queue. So I'm going to poll for messages, and you can see that we have one message inside. It's a notification, which is a wrapper sent by SNS when it's sending the message to our SQS instance. Now note the message ID here, which should uniquely identify the message. It also contains the topic that sent the message, and then the actual message details, and somewhere in here we should see the order created event. Now let's check if this message was received by our other queue. So let's poll for messages, and then we have 2 messages here. I'll choose the latest one, and if I search for the message ID that I copied, you can see that this is the same message that was sent from the SNS topic to our queue that was configured as a subscriber. So this is how we can configure publishing to an SNS topic and have the message fanned out to any subscribers. It's very similar to working with a queue, and all of this is abstracted behind the iMessage publisher. Now let's say you want to specify additional information when publishing a message. I'm going to copy the same endpoint again, and let's say we want to publish specifically to SQS. Well, there's an iSQS publisher abstraction, which you can use instead of the more generic message publisher to publish specifically to SQS. So here you can say await SQS publisher and then send async, and you can specify your message. So let's say the order created event, but we can also specify additional options with the SQS options type. And here we have access to some additional properties, like setting the message delay, passing in any message attributes, using a message group ID, which is required if you want to use FIFO queues. If I were to adjust this for SNS, I just need to switch from the iSQS publisher to the ISNS publisher. So let's go ahead and add the reference. I'll also change my service name, and now this becomes the SNS publisher, which exposes a publish async method. Here I can also pass in my event. along with the SNS options, and then this lets me pass in some SNS specific properties. Now there's also the iEventBridge publisher if you are using the EventBridge service. So depending on your use case, you can choose which type of publisher you want to use. And one last thing I want to mention is that this library also supports OpenTelemetry in the form of an additional NuGet package called AWS Messaging Telemetry OpenTelemetry. I'm going to tackle the OpenTelemetry support in a separate video, but I just wanted you to be aware of the support for this. So this is how we can integrate the AWS Messaging library into our .NET application. It's not a general purpose messaging library like Mass Transit that allows you to easily switch message transports. It's highly coupled to AWS, but if you're already using AWS services or you are planning to, it does contain everything you might need to send and consume messages from SNS, SQS, or EventBridge. If you want to grab the source code for this video completely for free, go ahead and check out the pinned comment right below. And if you want to learn how you could easily deploy your .NET applications into AWS, go ahead and check out this video next. Make sure to smash the like button, check out my courses if you want to improve your software architecture skills, and until next time, stay awesome.